Okay, let us continue on with Lesson 5 in the Lab 3, OSI Model TCP Utilities. We're going to discuss using commands to test network connectivity. 3 commands are especially useful for testing basic network connectivity. Packet Internet Groper, better known as ping, tracer in Windows, and tracer route in Linux. All of these commands use the ICMP protocol. Ping tests end-to-end connectivity, displays latency information, and determines whether the IP protocol is correctly configured. Tracer and traceroute takes ping a step further by displaying the same information for every hop or router between endpoints. These commands can help determine where a failure may have occurred in the network. Lesson 5.1 Testing network connectivity using ping, tracer, and traceroute. The basic syntax for the ping command is the same in both Windows and Linux. Ping host. Notice host is in brackets. Host can be an IP address or a DNS name. Pinging the DNS name can also help determine if DNS is resolving names correctly. So our first step is to type the command ping www.isp.com into the command prompt on the Windows 2K8 R2 Internal 1 virtual machine and press enter. And before we do that, I'm going to go ahead and close this ISP website. Take us down all the way to the bottom of the command prompt where we see our cursor. And we are going to ping or type in ping space www.isp.com. Notice the first line of the output. A DNS lookup was performed to resolve the domain name into its IP address. 4 ICMP request messages were sent to the remote host one by one. Each ICMP request message was replied to by an ICMP reply message that was recorded in the output. Each reply also shows the packet size, 32 bytes. The latency is less than 1 millisecond, and the time to live, TTL, is 127. The TTL determines how many hops, or you can call them routers, the ICMP packet will go through before the packet is discarded. Each hop lowers the TTL by 1. If the TTL reaches 0 for any reason, perhaps the fault of a routing loop, the packet will be discarded. This prevents a packet from looping indefinitely through a network. If the IP address of the remote host is known, the IP address can be used to ping. Type ping 131.107.0.200. Again, that's ping space 131.107.0.200 and hit enter. Notice the same information is provided, but no DNS lookup was performed. A user can also have ping resolve an IP address into a DNS name in Windows by using the -a command switch. Type the command ping -a 131.107.0.200, and I will walk you through that again. PING space, because we put a space between the command and the switch, -a space 131.107.0.200, and then we're going to hit enter. If a DNS name cannot be resolved, perhaps from a mistyped name or server failure, the command will error stating the host could not be found. If you do get that error, try retyping in the command for ping-a 131.107.0.200. If an IP address cannot be reached, or if pings are not allowed to do that host, the command will error stating request timed out. Moving on to step 6, if an IP address cannot be reached because a route does not exist in the routing table, the router will reply with an error stating destination host unreachable. Now, the tracer cert command in Windows can also be used with the IP address or DNS name. The main difference is that the output displays statistics about each hop between the endpoints. Type tracert www.isp.com into the command prompt, and I will walk you through that. On the command prompt at the cursor, type in TRACERT space www.isp.com and hit enter. The first hop, 192.168.12.1, is the default gateway, the Linux firewall in the topology diagram. The second hop is the remote machine. Using the command with the IP address of the remote machine produces the exact same output. The DNS lookup is automatically performed. Now, to compare this to the trace route, we're going to open up the backtrack virtual machine. And on here at the bottom, we're going to place our cursor. The traceroute command in Linux produces the same information, just in a different format. Now here, you're going to type in traceroute www.isp.com into the terminal window, like we did in the command window in the Windows machine. That is TRACEROUTE space www.isp.com and hit enter. If DNS can resolve the IP address of each hop into the DNS name, it will be displayed in the first column. Using the command with the IP address of the remote machine produces the exact same output. Now, you can close all open windows on the Windows machine. In conclusion, 3 commands are especially useful for testing basic network connectivity: Packet Internet Groper, better known as ping, tracert for Windows, and traceroute for Linux. All of these commands use the ICMP protocol. Ping tests end-to-end connectivity, displays latency information, and determines whether the IP protocol is correctly configured. Tracert and traceroute takes ping a step further by displaying the same information for every hop, router, between endpoints. These commands can help determine where a failure may have occurred in the network. Let's review a few questions. Question 1. What command tests only end-to-end connectivity in Windows and Linux? Well, that's the one we've been using for the most part. It's the ping command. It tests end-to-end connectivity. What command is used to test every hop between endpoints from a Windows machine? That would be the tracert command. Question 3. What command is used to test every hop between endpoints from a Linux machine? Well, the command is different for Linux, but it does the same thing, and that command is traceroute. This will conclude Lesson 5.